Hello, community. LangChain explained. A lot of my subscribers ask here for this video. So, what is the environment? I suppose we're gonna work with OpenAI, with GPT-4, and then I will show you LangChain. It's an open source initiative by the community. And of course, all the connectivities to external service provider with a commercial API. So this is the environment I'm going to talk today. Now let's start. We have here our OpenAI, our GPT-4, and there are a lot of other providers of LLM models, of large language models, but we focus today on OpenAI, but you can go with Hugging Face, you can go with Cohere, whatever model you like from whoever. So, and the task is a very simple task. We have question and answer. So let's have here our documents. Let's say we have 10,000 documents and we have a question about a specific content in one of those 10,000 documents, or about 100 documents that have cross references. So how do we start that we use here our LLM to analyze, use the artificial intelligence to come up with an answer given that this is our data stack? So beautiful. I'm going to do it in a way that I tell you, have a look at this video by the YouTube channel by Sophia Young. She is the one who's presenting the complete code. Whatever I present today, I build upon her video. She is only coding and I explain exactly what is going on and I show you, I paint the overall picture. So I have a very beautiful job today. If you go to her channel, maybe you like it. After 17 YouTube channels, I decided to go with her. She has also a Jupyter notebook in the description of the video, so you can download this and you can follow. So here we go. Now, first thing is, of course, you take all your 10,000 documents with millions and tens of millions of tokens, and you use here LangChain with a very simple command, 2 lines of code, and you say, okay, for the LLM, I take here my OpenAI, and I have a chain type, and this is just stuff it all together. Make one huge string of whatever. And this crashes immediately because, you know, in the current version, we have a 4K prompt. A 32K prompt may be coming up in the next month, but for the moment, we have everything that has a length more than 4K tokens as an input to the LLM will crash immediately. But there's a beautiful solution when you choose here the second chain type, MapReduce. You remember MapReduce 100 of years ago when we were programming in Databricks before PySpark was invented. Gee, my goodness. What it does is easy. It splits the document in a particular batch size and feed each batch into the LLM. So beautiful, you have then millions of batches and each batch is fed into the LLM and this is it. Now, if you want to be a little bit more clever, then you have the chain type refine. Refine is very easy. It takes the answer that it gets back from GPT-4 after it analyzed the batch number 1, and either there's 0, there's nothing relevant to the question in this particular text document, or it comes back with a summary or a short answer. And then this answer of batch number 1 is concatenated to the complete batch 2. So you see, the longer you go, 100,000, 10,000 batches, the longer you run, wherever, in whatever document, there might be even the slightest reference to your question, this information is extracted and you have a beautiful cross-reference over 10, 100,000 documents. And if you want to have a threshold, that you get a quality indicator, and you say, okay, for each batch I get now 50%, 70%, a 95% quality. So you say, hey, I want to have a threshold, everything below 90% ignore, everything above 91% take it and go with it. So this is a very easy way You take here your millions and tens of millions of tokens. And if you do this, you better do not look at the bill that you will receive, because remember that here OpenAI charges you based on the amount of tokens, and you have tens of millions of tokens, you are very fast into thousands of US dollars. So although this is a methodology, and if you say money doesn't care, whatever it costs, beautiful, you found your solution. Now for the rest of us, yeah, and then you got an official answer, of course. Now for the rest of us, we would like to spend not so much money. So how we do this? Now I told you LangChain here, an initiative by the community, open source. They found a very nice way, and it's called Retrieval question and answer chain. And of course, it uses the first method under the hood. So what we do, we pre-select our documents. This is all there is to it. Before we feed all the documents to our GPT-4 or any other LLM, we say, hey, in 90% of those documents, there's no information to answer my question, to execute my task. So therefore, we pre-select the documents. So how we do this? We need a reader, and LangChain gives us a reader, CSV files, data frame loader, emails, PDF, PowerPoint, Word documents. I think more than 100 reader are available. So whatever form your document is, you find it here in the reader. Beautiful. Second, if your PDF, as I just showed you, has, I don't know, 100 pages, you have to split it in chunks, because 100 pages, we do not get 100 pages in one rush here into our GPT-4 model. So you split up the documents in small chunks, in small pieces. What you know, NLTK text splitter, but you choose any text splitter that you like. Now it becomes interesting, because now that we have small text chunks, and you know what we want to do, we want to compare a semantic similarity to my question. So how we calculate semantic similarity in a computer? Yes, exactly like we have done for the last 10 years with transformers, with BERT models, with sentence transformer, with any vector representation of data in a vector space that we can construct out of the vocabulary of the data set. So we use embeddings. And just to show you, here, about 1 year ago, I made a video about the IPCC report, 3,600 pages, and I used exactly here a 3D visualization here of a sentence BERT embedding. So let me show you how does it look like. Here, for example, if I performed the embedding of 3,600 pages, this is now a 3D visualization where you see each dot, each cluster here. Each dot is a sentence, and the sentence is cluster and thematic cluster. And you see here urban climate, climate change, food security, global warming, decision making, decision uncertainty. So here you have now a 3D visualization of sentences that became here in a vector space, a vector, and you have all sentences of this report. You can then dive into, if you want to have the correlation between two specific topics here in a 3D visualization, these are all the different sentences and the vector combination. What else can I show you? You can have different correlation, you can have different topological analysis, you can have a cluster analysis. So whatever you want to do here, you can do amazing things. You can have, I don't know, you can define how many thematic clusters you want to have. You see here in 3,600 pages, I had close to 100 thematic clusters, and you can zoom in, you can have a detailed analysis of everything. So this is something we're familiar with. 2 years ago, 1 year ago, I had all detailed videos if you want to code this for yourself. And embeddings, you have a huge choice. Since we are working here, we want to work with OpenAI, we go with the OpenAI embeddings. So this means each word or each token is now transformed into a vector. A vector is a very simple representation in a vector space. If we have more complexity, we will go for a matrix and then a tensor representation, and then we will have a tensor space. So you see, we convert the text with the mathematics to simple mathematical objects, and we can calculate with simple mathematical objects, and we can use, for example, the cosine similarity function between vectors to find out if they are semantically correlated. So, and here you have now a vector database. And you say, database? Yeah, it's a simple old-fashioned database. Remember here 10, 20 years ago? So, and you have a lot of providers, and a lot of providers are professional providers, are commercially providers. They have here beautiful high-performance API. They are maybe cloud-based, whatever you choose here from this list. You take your credit card, you inscribe for 1 month, for 1 year, whatever your intention is, and cloud-based or not, you get an API key, so you can use now here the vector database, where all your transcription from the human readable text is now in a vector. Now, of course, in the old days, we just kept it on our local PC, on our local compute cluster. So you can also do this here locally, but if you have 10,000 clients, I would recommend going with a professional solution. So this is this. And then, of course, you want here to find the relevant parts of your document. I told you we pre-select here our document stack. You have your question. Now you take the wording of the question and you transform now each word or each whatever tokenizer you have, its specific token, into a vector. So then you have a vector representation of your query. Let's say, I don't know, 768 dimensional vector where this is your query. And then you compare here to all the other vectors that are based on your document, because you want to find semantic similar sentences or semantic similar paragraphs of text. And we go here over the mathematical construct of vector similarity in a vector space. And this is exactly what the famous retriever does. It just says, okay, I take my query vector, I make a cosine similarity operation, and the 10 most similar vectors I take, and either I transform back to human readable text, and then you can have a look at it, but suddenly all here your stack of tens of thousands of documents, suddenly you just have 10 documents. So you see what we achieved. We have now reduced here outside of OpenAI, outside of LLM, with here, if you want, some cloud professional service provider with some, yeah, of course, you have to pay for a weekly, monthly, or yearly rate, whatever you choose. We have now reduced here this pile of documents, let's say, to 900 words. And a lot of people ask me, what is an index? This here, those steps, the reader, the splitter, the vector database, or the vector store, or the vector hyperparameter, or however you like to call it, this is the function they perform. And what they tell you, either they give you exactly the sentences, or if you want, imagine this is a newspaper. Your document is a newspaper. What is the index? What does it mean? Index is just a page number. You look in the New York Times, for example, for, I don't know, financial news. And you find out now that on page 12 of the Financial Times, you have exactly the content that you're looking for. And the system tells you, hey, on page 45, there is a addendum, or there is some correction or some other important information. this is an index. There's nothing complicated to an index. It just extracts the corresponding relevant wording and gives you here, hey, page 12 of the New York Times and page 45. This is the information you get back. You do not have to read in this horrible stack here, but you have only 2 pages from the New York Times. So you understand what a long chain index is. For a given query, you get the relevant text back from your document stack. Your documents you downloaded from the internet, PDF, CSV file, whatever, 100 different forms of document can be calculated. So beautiful. And now that we have this, so now we do exactly like before. We have now the relevant text. Let's say there's I don't know, 900 words, and each word has 4 tokens. So we are below 4,000 token. Then we have the question. We tokenize our question. And we are below 4K for our prompt. You know, there again, we have different ways of chaining the information together. And then we just feed this in. And this is now all there is to it. If you have some external documents, whatever the form is, with your langchain index. Anything else that I forgot? No, I don't think so. Yeah, and of course you got back from OpenAI, from GPT-4. Your question was, hey, is this specific molecule in the biopharma environment toxic? Yes or no? And the answer is, yeah, the toxicity of this singular molecule is, for example, high. So this is all there is to it. And if you want the intelligent, is not happening now exclusive in your LLM because it's too expensive. So you, with LangChain, you are able to have a reader, a splitter, external databases, either professional, or you can do it also yourself. You do not need a professional service provider. But if you have, let's say, 100,000 APIs per hour, you should go with some professional. But you see, this is all there is to it. Now, of course, if you have now, let's say, some specific task and you do not know how to handle this task, so what we do? For example, I connect here to ChatGPT. I have here my prompt. I say, hey, ChatGPT, I have this problem. How would you structure here my action point to come to a solution so that I can handle this problem? And this is exactly what in LangChain an agent is doing. This is the job of an agent. So an agent asks the intelligence, we say we go with OpenAI, GPT-4, what to do given a specific topic, problem, whatever. So it tells them, hey, create a list of action item for breakfast. And then what we get is now in response from GPT-4, it tells us as an answer, this is your first action you can do, the second action you should do, and the third action you should do. Beautiful. So now we know what are our action points. And we have, as an agent in LangChain, we have here tools and toolboxes and whatever you call it, we have tools. What are those tools? Those tools are data pipelines to commercial service provider. What you know, for example, SERP API. If you say, I need here to connect to Google search, I have a specific question to Google search, and come back with the answer from Google search, which of course you just could go to Google, type in your question, and string copy your answer, but we want to automate it. You have here a service provider, SERP API, and if you go for a semi-professional version, it's $50 per month, or if you go for the professional version, it's $250 per month. And you have so many service providers. And the tools that an agent can use now is, I don't know, I think there are more than 300 service providers available on the internet. Some are free, some are on a freemium-based model, and some simply say, hey, provide us your credit card details, and we are happy to provide our professional service to you. So you have Wikipedia, you have Wolfram Alpha, you have weather channels, you have ChatGPT plugins, you have Bing search if you do not like Google search, so you choose. And the last one you see in the list is Zapier, and there you have access to more than 5,000, I think it's more than 5,000 apps right now. So it is an unbelievable amount of professional service provider that you can connect to. And if you have an account there, if you already pay for some of their services, I would say check out if they have a compatible tool for LangChain, your agents. If not, you have to pay for whatever service you need. So, beautiful. Now, the first action, as I told you, was go and perform a Google search, an automated Google search. Use the APIs, ask the question, and come back with the question. Beautiful. So we have now here text that is the answer to the first action item. The second action is, okay, and now you have to connect to a very specific finance database. I don't know, where you have ID and authorization, and of course you have to pay for API access. But if you want some specific market data, financial data, whatever you want, this is now the second action. Connect, ask your question, get the answer, and come back with the answer. And let's say the third action was exactly what we did here before. We had here a question for these documents. Those are my documents, my internal documents. And now I have here my internal documents. So I have, if you want, a generic Google search. I have a detailed financial database search. Either you go with SQL or NoSQL or whatever database. There's so many service providers out there in the internet that will do and will provide the job. And the third action is here my personal accounts, for example. So you see, this is it. And the agent now comes back from using all the different tools that he needs for the job. And whenever he encounters a problem, he goes back to GPT-4 and asks for help. And GPT-4 tells the agent what he should do next. So you see, the agent is just a list, where the list is 1, 2, 3. When you go shopping, we need butter, we need milk, we need bread. This is it. An agent is, imagine this simply a list you do when you go shopping. The real intelligence is, of course, within GPT-4, within LLMs, within all your AI systems. Because those are just databases. Those are just whatever you need. But the intelligence is here. But remember, every time you connect back to ask for advice, you have to pay. So just to make sure it is not as bad as here, but you have to pay because you need the intelligence from GPT-4. So beautiful. Now you have your agent. So, and now you know what's coming, because now you can chain this information together. You have a highly dense information, 1, 2, and 3. You remember you have 4 ways to chain here information together. And if you have chained it together and you validated it, the moment comes that it sends it off. Now this highly complex agent model here with our new prompt, and we feed it into GPT-4. And you're not going to believe it, after some time we get an answer back, and the answer is, for example, the toxicity of this financial derivative XY, I don't know what, a bond structure, is high. So whatever your original question was, now you have an answer based on your financial accounts, based on a specific Google search on the risk of this financial product, and you also had here access to an expert database, a finance database, where you checked the, I don't know, performance of the last 5 years that were confidential. So you have here a complexity of interaction that LangChain is really helpful to perform for you. So again, LangChain is open source, but whenever you need a commercial and a for-profit service provider to provide some service for you over LangChain, remember, you have to pay them first. You get your API key, and then the whole thing starts running. So this is it, and I say thank you. And if you're interested in a practical example, I got a lot of question. Can you live without LangChain? Can I do, if I just go for 1 or 2 times, can I do it without LangChain? And the answer is, of course, yes. Let's have a look at some funny example. You know, there are so boring examples. So here we have LangChain, here we have read the docs. As I showed you, we have 6 modules. We have the LLM model, we have the prompt, we have what I showed you is the index. Memory is just that somebody is constantly writing what you are doing. And we just had a specific look at chains. And now agents. And agents was also in my last slide. But you know, if you want to know if you can do what an agent does without LangChain, imagine this. Here we have our beautiful agent 007. And of course, as an agent, he has his tools, you know, and provides him with some, I don't know, some beautiful car or whatever, an aeroplane or whatever. So, and then as an agent, normally here within LangChain, you ask an intelligent LLM what to do. If he doesn't know what to do, system goes back here over LangChain to GPT-4. Now imagine this here now on a human level. So our beautiful agent 00 nothing ask now Moneypenny how to prepare, or for a specific task, how to prepare breakfast. Now Moneypenny provides him with a list of some detailed instruction that he has to work on. This is exactly what our LangChain agent would do. Now we have here 007 doing exactly the same way. And you remember, tools are ways that an agent can use to interact with his environment, with his ecosystem, with other agents. So beautiful. And if you ask for the tool, yes, again, this is the list of tools. And do not forget, I've seen a YouTube video where there was a competition, how many microservice provider you can subscribe to and for LangChain. And there was one who subscribed to 16 professional service provider, so credit card, name, security code, and gets the API back. And it was done in under 1 hour. So if you want to have a benchmark, if you sign up with your credit card for all the external provider, it can be done for 16 under 1 hour if you need this. But if you now think about what would be an example here for LangChain or without LangChain for our agent, imagine the job to be done. Now, if we are talking here about breakfast, what would happen? Now, the artificial intelligence system would connect via a LangChain agent to the SERP API to ask Google for some ideas for your breakfast choice. And Google would return about 125 documents on different breakfast options. Now, the other person or other system or whatever you're interacting with, so let's say her LangChain avatar provides also her personal preferences. So what happens? You bring those data together in your vector store analysis, and there you have a cosine similarity operation where from those 125 breakfast options, based on your physical condition in the day, your detailed preferences, her preferences, a set of 10 breakfast choices is now calculated via a cosine similarity and the specific question that you ask for. This is the job. So if you have then this set of 10 breakfast choices, 10 is a small enough number that we can enter this as an input to our OpenAI API for GPT-4, and GPT-4 performs on highly intelligent ranking. Given that those 10 breakfast set has to be analyzed given the situational appropriateness those two agents are currently interacting with. And of course, there's a winner, and GPT-4 returns here one breakfast option, say, hey, given for you two, this is the best breakfast for the particular job. So GPT-4 comes back with an answer, instructs now a different LangChain agent, for example, to buy the ingredients online or buy the products online for coffee beans, a specific bread, champagne, whatever you like for breakfast, and have, of course, instant home delivery. And now it happens that suddenly one LangChain agent says, hey, wait a minute, there was something. So there was an unforeseen activation of an agent, and ask ChatGPT or GPT-4 here for some corresponding music for this particular type of breakfast. So again, you use the intelligence of LLM to find here the perfect music for this particular breakfast, for this particular situation of our two agents. And then another agent activates, connects to the API of the music stores, pays there with your credit card, orders it online, downloads it immediately, and instructs Siri to play the music for the breakfast. So you see, this would be here now a non-standard example that you see exactly what LangChain is doing, interacting with an LLM and interacting with external professional service provider. And so if this would be the job, this could be here exactly what is happening under the hood. And now it is up to you if you want to decide if you are in this situation and you have given here as an agent a particular job, if you want to apply LangChain or you enjoy your professional life without LangChain. I say thank you and I see you in my next video.